So, welcome back students. Now it's time for the homework on mechanical energy and electricity production from biofuel. What you shall do is to prove that you understand what the Carnot limit actually means and that you understand how to think when it comes to the planning of a bioenergy plant. And to do that, you shall solve quite a complicated task, so let me first explain to you the background. First of all, read all the chapters in column 4 in the Busy Plan Handbook, and also make yourselves comfortable with a spreadsheet and put special emphasis on the sheet for forest resources. We will now assume that you are responsible for the planning of an energy plant in the outskirts of a small city. The city has 12,500 inhabitants, and it is to 100% connected to a district heating system. The load on the district heating system varies across the year, with a maximum at 50 megawatts in December, January and February, while in May, June and July it has a minimum at 10 megawatt, and then it changes during the other months. The water coming back from the district heating system, the return water, is used to cool the exhaust steam from the turbine in the electricity production. The temperature in this water is different across the year, with a minimum of 50 degrees during May, June and July, while during winter, December, January and February, is the temperature 65 degrees Celsius. And again it changes during the other months. Through different handling does the energy company adjust the fuel quality a little bit, and during winter, November, December, January, February and March do they use the best fuel, and then they have a combustion temperature at 1200 degrees. In June and July they use the very worst fuel, and then they only have a combustion temperature at 1050 degrees. The other months the combustion temperature is 1100 degrees C. The total efficiency of the plant reflects the total load of the plant in combination with the fuel quality. And peak values, 94%, are reached during December, January and February, while only 90% is reached during May, June and July. The Carnot limit thus changes from one month to the other, since the high temperature is the combustion temperature and the cooling temperature is the return water temperature. The electricity efficiency is 70% of the Carnot limit during all months. Now, to compute the monthly fuel input energy and the electricity production in megawatt hours, you will use the equations shown in this slide. You will notice that the total process efficiency as well as the Carnot limit will change from one month to the next. So you should make use of your skills as a programmer to set up and calculate the monthly data. You will find that the monthly need of input fuel goes from a maximum exceeding 65 gigawatt hours per month in winter and down to some 13 gigawatt hours per month during summer. Now use the Busy Plan spreadsheet and assume you can collect wood residues from stands of spruce trees. The trees are 15 meters high. The crown starts at 2 meters height and the breast height diameter is 35 centimeters. The number of stems is 1000 per hectare, which means that the distance between the trees is a bit more than 3 meters. The time for the trees to reach this size is 30 years. You can only collect 10% of the annual growth for energy, and that is because 40% of the tree weight is used for pulp, and 40% is used for timber, and 10% is the stump, and in unrecoverable parts lost during felling and forestry. So the question is, how many hectares of forest land do you need to harvest to supply the energy plant? If this land was a circle around the energy plant, what would the radius become? If you did not use CHP technology, but used condensing power production instead, then the theoretical total efficiency of the plant, as seen in slide number 4, would be set by the Carnot limit. But on the other hand, you might be able to use a coolant temperature at some 10 to 15 degrees Celsius all around the year. Use the data you have now obtained and the data from this example to play around and really learn how to use the spreadsheet. Also spend time thinking about how different systems and sizes, as represented by the in-data table on slide number 4, will put different demands on infrastructure, on logistics, and on storage capacity.